So on polynomial online review, the first problem told us to divide p of x by b of x. And p of x is this long polynomial, fifth degree polynomial, and divided by x minus 4. Now we can do that two ways. We can either do long division or we could do synthetic division. Since it's just a simple binomial, I chose to do synthetic here. So yes, you do need to write this down. Somebody asked if we need to write this down. I said that earlier. Yes, you do need to write this down. So people who came into class, maybe you didn't hear that. You need to write this down for your classwork today. So number one that you're going to write down is x to the fifth minus 2x to the fourth minus 6x to the third plus 2x squared minus 55x plus 60 divided by x minus 4. So that's our problem. I always like to see the problem on your homework assignment. Some of you tried to squeeze in the answers onto the worksheet. That wasn't a great idea. I'd rather you do it on a separate sheet of paper so that you have plenty of room to show your work. Okay, so if I take this and divide it by that, x minus 4 is equal to 0, right? That if that's a factor, then we need to solve this by adding 4 to both sides like this, and we get x equals 4. So since 4, we get x equals 4. That's what you put outside your synthetic division. So to set up our synthetic division, we take the leading coefficient is 1, so the 1 goes here. The next coefficient is -2. The next coefficient is -6. The next coefficient is +2. The next coefficient is -55, and the constant at the end is 60. So that's what you're writing down right now. And I'm going to check who is entering class. I had a couple people enter late, not sure why. Take a second to write that down while I take a picture for roll. I need to take a picture of the roll participant list here. Okay, that's fine. If you enter on the laptop, that's fine, as long as you are paying attention to the Zoom. And Mr. Whitman, sometimes I like to circulate around the room, but I don't like to circulate too closely to the students just because they might not be comfortable with that, or I'm not comfortable with that. So I'll actually go out the classroom and behind the windows right there, just kind of look at, you know, what's on their laptop and stuff like that. So just a little tip that I use there. Okay, so now that we have set up this synthetic division, review of how synthetic division works. You bring the 1 down first. You don't do anything with the first number. You bring it down. Then you multiply. 4 times 1 is 4, so we put a 4 here. Then we add these two together. 4 plus -2 is 2. Then we multiply. The 4 times the 2 gives us 8, so we put an 8 here. Then we add the 8 plus -6, that gives us 2. Then we multiply. 4 times 2 is 8, so we put the 8 here. Then we add 2 plus 8, and we get 10. Then we multiply. 4 times 10 is 40. Then we add -55 plus 40, and that's -15. And then 4 times -15 is -60. And then negative and positive 60 cancel out to be 0. So this is a 0. It means that 4 is a solution. X equals 4 is a solution to this. If we plug x equals 4 in, we would get 0, right? We learned that from Professor Leonard's video, that if you plug in p of 4, we're going to get 0. You know, you'll get a bunch of numbers added and subtracted, and it'll become 0 because this is a 0. So that's where one of the places that the graph crosses the x-axis at x equals 4. Okay, this is not your answer though. We need to go a step further and write what the correct answer is. So if I want to take this and divide it by this, so what this 1 means is we reduce the x to the 5th by 1 factor, 1 degree, because you're dividing x to the 5th by another x. So if you take this degree down 1, you get x to the 4th. So this is 1x to the 4th. Plus 2x to the 3rd, plus 2x squared, plus 10x minus 15. So if you were to take this whole x to the 5th polynomial divided by x minus 4, you would get x to the 4th plus 2x to the 3rd plus 2x squared plus 10x minus 15. All right, so that is how you divide synthetically. We could do it long division wise, but for this problem, we don't need to do that. For number 2, okay, number 2 said this. Let me erase some of this. Number 2, 1 second. Okay, muting everybody so I don't hear background noise because I was hearing some background noise. For number 2, let me change color here too. Find all the roots of y equals x to the 4th minus 5x to the 3rd plus all this stuff. Find the roots of this polynomial. Okay, so if we're going to find the roots, we need to use the rational root theorem. We have to use the p over q thing, right? P divided by q. So go ahead and write the p divided by q. Go ahead and write this down too. Y equals, I always like you to write the problem down. Y equals x to the 4th minus 5x cubed plus x squared plus 25x minus 30. We want to write that down for number 2 on your notes for today that you're going to turn in before the end of class. And then to find these roots, so your p value is all the factors of the last number. Your q value over q is all the factors of the first number, the first leading coefficient. Our leading coefficient here is 1. So we want all the factors of 30 on top and all the factors of 1 on the bottom. And we're going to put plus and minus of these, right? That's our p over q. So I put it way over here. You don't have to put it way over here. But our p over q is, and this box is in my way. Let me move it out of the way. Is the factors of 30 are 1. You always, 1 is a factor of everything. So positive, negative 1, positive and negative 2. 2 goes into 30. 3 goes into 30. 5 goes into 30. 6 goes into 30 because 5 times 6 is 30. 10 goes into 30, and I left a couple off here. Other one, 15 goes into 30 because 30 divided by 2 is 15, and then positive and negative 30. So I didn't have room, but I left those off. So those are all our factors. So that's what you should be writing down. P over Q is, so these are all our possible numbers that could go into this root. So theoretically, we'd have to test all, whatever, 10 of these numbers. But you don't have to test all 10 of them because you're going to find the roots pretty easily. So I used Professor Leonard's method where I plugged in the number. First, he said try one. One usually works, so it's the first one you should try. You should always try 1 first, positive or negative 1. So I plug in 1. It didn't work. I got 1 minus 5. When I plugged it in, I plugged it into here. I got 1 minus 5 plus 1 plus 25 minus 30. And I could see that wasn't going to equal 0. So I just put not equal to 0. Then I tried negative 1. I got 1 plus 5 plus 1 minus 1. This is way too much. This is not going to cancel with all this. So that's not equal to 0. Then I tried 2. And I think 2 worked. Yes, 2 does work. I got 16. Let's see. I plug in 2 here. 2 to the 4th minus 5 times 2 cubed minus 2 squared plus 25 times 2 minus 30. So this is the work I meant to put here, but I stopped for some reason. But later on I finished. I just didn't take a picture of it. 2 to the 4th is 16 minus 5 times 8 is 40 minus 2 times 2 is 4 plus 50 minus 30. Okay, and this ends up being 0. Okay, and so when you do all this, you get 0. So that tells me 2 is going to work. So down here, I've done the synthetic division. So we're going to put 2 here, and then we're going to put all these numbers here, all the coefficients. We're going to do 1 first there, then we're going to do negative 2. I'm sorry, I'm on this one. 1, negative 5 right here, 1 here, 25 next, and negative 30 last. So this is how we set up our synthetic division. Then we bring down the 1 right? And then we multiply. 2 times 1 is 2, so a 2 goes here. Negative 5 plus 2 is negative 3, so negative 3 goes there. 2 times negative 3 is negative 6, so we add the 1 and negative 6. We get negative 5. We multiply 2 times negative 5, that's negative 10. We add 25 and negative 10, that's 15. We multiply 2 times 15, that is 30. And we get 0. We like it when we get 0. You should have, on your homework, the other homework assignment, your search for roots, you should have got a bunch that you didn't get 0 for, right? Like here, I didn't get 0, I didn't get 0. There should have been a bunch of times when you don't get 0. So here's the roots. I wrote them all down here. So I know this is going to work. So let's write this as a polynomial. We started with x to the 4th, so I'm going to reduce that x to the 4th by 1 and make it, this 1 means 1x cubed. Minus the next one is 3x squared. Minus the next one is 5x. Plus the last number, our constant, is 15. So this x plus 2 means x minus, this x equals 2 means x minus 2, right? If you have x equals 2, you subtract 2 from both sides, you get x minus 2 equals 0. So that's why you have to make that 2 an x minus 2 for your factor. Then we factor this again. Well, this is a group of 4 things, so you're going to factor by grouping. So I look at what x to the 3rd and 3x squared have in common, and I take that out. Well, they have an x squared in common, so I took out an x squared here out of these two, and I'd have to multiply x squared by x to get x cubed minus x squared by 3 to get 3x squared. So you factor these two first, right here. Then I'm going to factor these two, so I'm going to group these two together, and I'm going to take out, what do 5x and 15 have in common? Well, they have a negative 5. Why did I choose negative? Because this is a negative. Okay, and that's going to leave me with, I have to multiply negative 5 by x minus 3 to get negative 5x plus 15. And these should always match. These two right here should always match when you factor. This is called factor by grouping. Okay, we did, it was on one of the worksheets that we did. So since these x minus 3s are together, you combine them into one parentheses, and then you put the x squared minus 5 into their own parentheses. So this becomes a quadratic factor. You have another singular linear factor, and then you have the x minus 2 factor. And if we could factor this again, we would, but we can't factor this. If I solve this, I get x equals positive and negative square root of 5. So one of the roots is a square root. But that's beside the point. We leave it like this. And that is how you factor completely number 2. But it says, actually, I just noticed this says find all the roots. It didn't say factor. So if I want to find all the roots, I actually do have to solve this. So you have to set these equal to 0 and solve them. I set that equal to 0, set that equal to 0, set that equal to 0. If I set this equal to 0, I get x equals 2, x equals 3, and x equals positive and negative square root of 5. So those are the zeros. That should be my answer right there. Okay, so that is number 2. And test is going to be very similar to this. All right, I got to clear these drawings, so I'll give you a second to finish copying down whatever you need to copy down from there.
Would the x squared minus 5 look like a double root on a graph?
No, because one's positive root 5 and one's negative root 5. So they're on opposite sides of the y-axis.
Oh, okay, thanks.
Okay, so next, number 3. Okay, write a polynomial with integer coefficients. Oops, sorry, I lost it. Write a polynomial with integer coefficients in factored form with the following roots. Leave your equation in factored form with linear and quadratic factors as appropriate. So we know that our polynomial has these roots. Basically, it crosses the x-axis at this point, and this point. And if it's this point, there's another point that goes with this. Does anybody know what other point goes with this? trying to get my pen back. Nobody knows what other point goes with that. What's the conjugate of 2 plus the square root of x, guys? Conjugate.
2 minus the square root of x?
Yes, the conjugate, if you have like a complex number like this, the conjugate is also going to be a root. They just don't necessarily tell you that, but we assume, and it's okay to assume, even though, you know, we say not to assume because it makes something out of you and me. But the opposite of 2 plus square root of x is 2 minus square root of x. So that is actually going to be a root. So this is actually going to be not, you might think, oh, this is degree 3 because we have 1, 2, 3, but this is going to make it a degree 4. So our answer is going to be a degree 4. Okay, so if we know this is the root, is it okay if x equals -3, I'm just going to add 3 to both sides, right? So this is one of the factors is x plus 3. That's easy, right? If you know one of the roots is -3, the first factor is x plus 3. If x equals 4, then we minus 4 from both sides. So the second factor is x minus 4. Those should be super easy to come up with, like 2 seconds. The harder one is, how do I come up with this factor? You can't put x equals x minus 2 plus square root of 6. You will get 0 points for that, okay? So you have to get rid of the square root. So to do that, so let's write this. X equals, we know one of the roots is 2 plus square root of 6. So you're going to write that down. X equals 2 plus square root of 6. Well, we know we have to square the problem, but don't square the problem right away. Let's minus 2 from both sides first, like this. So you get x minus 2 equals the square root of 6. Now square the problem. After you minus the 2, square it. And when you square x minus 2, you square that, you get x squared minus 4x plus 4, right? If you don't believe me, use your generic rectangles to get that, okay? To get x squared minus 4x plus 4 equals, and then square root of 6 squared is 6. Then bring the 6 to the other side. So we're going to minus 6 over here, minus 6 over here. 4 minus 6 is -2. So now you have this quadratic factor. And that is your last factor, x squared minus 4x minus 2. This quadratic is going to give you 2 answers. The 2 answers it's going to give you is 2 plus the square root of 6 and 2 minus the square root of 6. So it's going to take care of both of those roots right there. So this is a degree 4 problem. You would want to write that out, show that on your paper. It doesn't ask for that, but these are things that you should show. Okay, and that's how you come up with it, pretty easy. All right, so the next problem, we know the roots are 5, 5, 100, and 3i. I'm gonna erase some of this so it's not so messy. Okay, I'm gonna change my color too. So that's an easy root to make, that's an easy root to make. X minus 5 twice, well, that's a double root, right? So that's x minus 5 squared right away. It takes 1 second to do that, right? So I just made this one q of x. So this is part B. Q of x, you can use p of x, you can use q of x. We've been using p of x and q of x a lot in this. So you can call it whatever of x you want. You could call it f of x. You could call it t of x. It doesn't matter. Q of x equals x minus 5 squared. The 100 is going to be x minus 100. So times x minus 100. The 3i, you can't put x minus 3i. You're not allowed to do that, okay? If you do that, it's wrong. So you can't have i's in your problem ever. You never see i's in these polynomials, but they're there. They're hiding, okay? They're hiding in this form. So how do I get 3i to be this? This is what we do. We put x equals 3i, okay? So, sorry, you can't see that well. It says x equals 3i. There, you can see it a little better now. And then you're going to square both sides. After you put x equals 3i, you square both sides. Well, 3i times 3i is 9i squared. So I didn't show this step because I just did it in my head, but you should show it. You should show me that you know this. I squared we know is -1, right? 9 times -1 is -9. So x squared equals -9. Then we're going to add 9 to both sides, add 9 to both sides to get 0. So the last factor is x squared plus 9, and that goes right there, x squared plus 9. Okay, so we have, what degree is this? X squared, x, and another x squared.
5.
That's degree 5, that's right. Okay, and just write that down. Even though the problem doesn't ask me, you know, it's good to know, just so you know, like what the graph is going to look like. I know the graph's going to look something like that, okay, because it's a degree 5. And speaking of graphs, that brings us to number 4 here. Somebody in the chat asked, how do you figure out the degree here? You count the number of x's there are. This is an x squared, so that counts as 2 x's, so that's an x squared. This is just an x, that's so times 1 more x. And this is another x squared, so times another x squared, and you count how many there are. There's 2, 3, 4, so this is x to the 5th. So there are 5 x's in this problem. So there's 2 here, there's x times x here, there's x here, and an x squared here. So there's 5 x's, so that's degree 5. Okay, number 4, how do we sketch this possible graph here? And we need to figure out the degree to figure out what it looks like. Don't try to scale the y-axis. So in other words, we don't expect you to be super accurate with this, okay, just like a sketch, okay? If I did see an accurate graph, I would just suspect that you put it into Desmos, and I might not give you credit for that. If I see a graph that came straight from Desmos, I'm not giving credit. Okay, I need to see a handmade graph, a human-made graph, not a computer-made graph. Okay, so let's see what degree this is. Let's count. Somebody just asked, how do you find the degree of this? Let's count how many x's we have. We have 2, 3, 4. We have 3 here, 5, 6, 7, 8, 9. So this is a degree 9 problem. Degree 9, we know, have opposite end behavior, right? One side's going to go up, one side's going to go down. And I noticed that there's a negative out in front here. That's important. If there's a negative out in front, it's going to have a negative orientation, okay? It's going to ask you that on the test tomorrow. What orientation does this have, positive or negative? And your answer is either positive or negative. Positive would be it's going up. Negative is it's going down. Well, this one's going to be going down because there's a negative sitting out in front there. So it has a negative orientation. Okay, so this one is negative. So I know it's going to end like this, not like this, right? The left side is going to go up and the right side is going to go down. Okay, now let's list our roots, our zeros. So if I start with this, what is this 0? If I do x squared equals 0, what is that? That's x equals 0. And it's a double root because it's a squared. So I write double above it to remind yourself this is a double root. Then this root, well, that's x equals -2, so that's your next root. This root is x equals 1. This root is x equals 3, but triple. It's a triple root because it's cubed. So 3 is a triple root. This is x equals 6. This is x equals 10. Those are all our roots. Those are 9 roots there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of them are double and triple, which is nice because that means we only have to graph those once. Now you want to put these in order, because I tried to do these without putting in order. My graph came out really kind of messed up. So let's put them in numerical order. -2 is the smallest number, so I'm going to put it here. Okay. Then 0 is next, and it's a double root, so I put ×2. Is that what that says up there? Then 1 is next. Then 3 is next, and it's a triple root, so I put ×3 above it to remind myself this is a triple root, and it needs to reflect that in the graph. Then 6 is next. Then 10 is next. Why do I put this in numerical order? Because now I'm going to do my graph, and I want to go from left to right. I know it should start up here. It has to pass through -2, so here, let me do this here. Has to pass through, I'm going to put -2 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you don't know what the graph looks like, so we're starting with a blank graph, right? So we know it goes through -2. I know it has to go through -2, and I know it starts up here, so I'm going to go like this. So it starts the graph like that. Then I know my next point is 0, and it's a double root, so it has to now go up here, but it has to bounce off of here because it's a double root. Then it's going to pass through 1, which is really close to here, so oh, I have to come back up. Then it's going to pass through 3, so that means I have to come back down. Then it's going to pass, oh, sorry, 3 is a triple root. So there I have to do something special here. So let me reverse that a little bit. Undo, undo. Okay. So since this is a triple root, I might want to go a little higher, and I need to show an inflection. Okay, it needs to go like this, right? Triple roots, that's what triple roots do. They inflect, they change, they flatten. Remember we talked about that when it flattened? I remember that from a couple weeks ago. Okay, so it flattens and it goes like that. And then I need to come back and go through 6. So I don't know, maybe I could show that a little better. I'm just gonna flatten it a lot. You need to exaggerate it, right? Flatten it and then come back up to 6. And then my last root is 10. Then I know it needs to go back to 10. So to go back through 10, I go, and then is it pointing in the right direction? Look back at your little, you should do like a little sketch to remind yourself, oh yes, the right side is pointing downwards and the left side is pointing upwards. So I probably did this right. Okay, and my inflection is there. So this is a sketch. You see this, my first sketch looked a little different than my second sketch. That's because this is not exact. Right? If I see an exact Desmos answer, you're getting 0 points. Okay, this is not an exact science. Okay, so I should see something like that for your graph there. All right, next. Number 5. We're going to sketch the graph of x to the 4th minus x to the 3rd minus 4x squared minus 20. So let's go ahead and write that down. Let's sketch that graph. So f of x equals x to the 4th. Want to make this graph, okay? Well, in order to make the graph, you need to find some zeros or factor it. It says factor and find the roots first. Okay, let's see. To factor this, there's a couple different things we can do. And notice they all have an x, so let's take an x out. So if I take an x out of the whole thing, reduce all these by one factor of x, x to the 4th would become x to the 3rd, 5x to the 3rd would be 5x squared, 4x squared would be 4x, and the 20 would no longer have an x, right? If I take an x out of all of these, it would reduce the x values by 1. So I factored out an x. Now we're going to use factor by grouping because we have 1, 2, 3, 4 things. When you see 4 things, you should think, oh yeah, factor by grouping. Factor by grouping, that's a thing that we need to use. So we need to group the first 2 together and then the last 2 together. That's why it's called factor by grouping. And I need to see this on your paper. Okay, I need to see you group these 2 together. So this x that's sitting out here, let's just leave it out here, right? That's a x equals 0. That's one factor right there. Hold on a second. Somebody's asking me something in the chat, so I have to pause and check it. Because they all have, why did I take it on x? Because they all have an x. That has an x, that has an x, that has an x, that has an x. So factor out an x to simplify your problem. So after you take out the x, now I want to factor these 2. What comes out of x cubed and x squared? What do they have in common? What can you factor out of that? Well, they both have an x squared that I can take out, right? I can take out an x squared out of here and here. If I remove an x squared from here, I have a factor of x left plus 5, okay? Because we have that x squared plus 5 like that. And then what can I take out of 4x and 20? What can I remove out of those 2 that are grouped together? Well, I can remove a -4 out of there. So if I remove a -4, that leaves me with x minus 5. And look what happens, just like the last problem that we did, these 2 end up being the same. Sorry, that should be x plus 5. They need to be the same, so they have to have a plus. The minus is already out here, so -4 times +5 is -20. These need to be the same. Now that they're the same, you can combine them into one parentheses, x plus 5. You're basically factoring them out. You're taking this one and this one out. And then you're going to put the other 2 factors in their own parentheses, x squared minus 4. These 2 that are outside the parentheses go in their own parentheses. And then this x that we had in the beginning, that we factored out in the beginning, goes there. So f of x is equal to x times x plus 5 times x squared minus 4. Check your degree to make sure it's the same as the beginning. This was a degree 4 problem, right? Degree 4. So we should have 4, and we do. We have 2 here, 1 here, 1 here. So I factored it, and it's the same amounts. The 0, so this is the first 0, x equals 0, right? And then this is x equals -5. And then when I solve x squared plus 4, or x squared minus 4 equals 0, I'm going to add 4 to both sides, or I could factor this, either one. X squared equals 4. So it's x squared equals 4. Take the square root of both sides. X equals positive -2. Okay, so those are, so I have positive 2, negative 2, 0, and 5. Those are my 4 zeros for my degree 4 problem. So here is, and I know since it's degree 4, it's going to be like a W, right? If it's positive in orientation. If it's negative orientation, it's going to go down. But this is positive, so there's a positive leading coefficient, so it's positive. It's going to go like this. Okay, so put your numbers in order. So put the zeros in order. I put them in order. -5 goes first, right? So if I put them in order, -5 goes first. Sorry, these were -5. And was it a double root? Wait, no, it was not a double root. Oh no, we factored it out. So -5 goes first. I forgot the negative here. This is negative. So -5 goes first, then -2, then 0, then 2. We had a positive and -2, and then we had a 0. So that's the order. So -5 goes first, then -2, then 0, then +2. So that's all you know. So I'm going to come down through -5, come up through -2, come down through 0, and up through +2, like so. Okay, yes, I will slow down a little bit. Somebody said I was going too fast. Oh, whoa, sorry. What happened? Okay. Okay, so sorry, I erased all that writing on accident because I accidentally pressed. It's very easy to bump all these buttons on the control panel here. I have a million controls on Zoom. It's really fun. Okay, so we go to the next one. So that is how we got all the zeros, we put them in order, and then it went through -5, through -2, through 0, and 1. Voila, that is, so this is the work I'm talking about. I'm serious. Some of the work that I got on the homework, I'm like, that's not work. Okay, you guys got to show some work on your paper. It took me 2 pages of work, and most of you turned in one page or half a page of work if I cut out all the pictures. So make sure you show work. All right, so number 6, write the exact equation for this graph. We know the y-intercept is 0, 945. So they're telling you a point. They're telling you an x and a y. There's a reason they're telling you that. That's because you're going to have to find the a value. You're going to use that to find the a value, right? And so let's determine what type of problem is this. What degree is this? Is it odd or even? How do we know if this is odd or even, guys? Well, the left side is pointing up, the right side is pointing down. So is their end behavior the same or different?
Different.
Different. So if it's different, is it an odd function or an even function? Odd. Right. If they go in opposite directions, it's an odd function. So that means this is either degree 3, 5, 7. For sure, I know it's not degree what? It's not degree 3 because it has too many terms to be degree 3. It's either like 5, 7. It could be a 9. It could be 11. It's some odd number. But since it's this complex, it looks like a degree 5 to me, doesn't it? To you? But let's find out. Okay, so let's mark the zeros. We have to find out where our zeros are. Well, those are in the graph. Here's 1, 0, right? What point is that? x equals -3. Is that a single root, a double root, a triple root? What is this? It's a double root because it bounced off of -3. It didn't go through -3, it bounces off, so we know it's a double root. So how do I write x equals -3 as a double root? X plus 3 squared. So that's, I have a degree 2 so far. I need to add some more degrees because this is not a degree, it's not an even power problem. So our next root passes through right here at 1, 2, 3, 4, and 5. So it passes through 1, so I could just write x, this is +1, so it's got to be -1, right? X minus 1 equals 0. X minus 1 equals 0 will give you 1, okay? Then it also goes through 3, and that's a singular root because it's going through the point. So x minus 3 also. And then there's one more over here. Ah, that's at 7, right? Here's 5, 6, 7. So x minus 7. So let's count our degree and let's put y, or I'm going to write p of x. P of x equals this. We need to make an equation. So let's count how many roots we have. We have 2, 3, 4, 5 roots. So this is degree 5. Write that on your paper, on your test, please. Show me that you know what degree this problem is. It doesn't ask you to put it, but the point of a test is for you to display how much knowledge you have, not to put as little work as possible on your paper. You need to show me as much as you know. Does it say, tell me the degree? No, but you should put that to show me that you understand that this is an x to the 5th power, that you understand it has to be odd, that you understand the end behavior has to have opposite behavior because it's an odd problem. So degree 5, if you put that, that tells me, okay, this person understands that an odd function has to have opposite end behavior because they put degree 5 on there, okay? So, okay, what's this other work over here? So we have this function right here. Now we need to find the a value. So let me add an a to this because actually this is just a possible function. We need to put an a in front of here. I need to change colors, it didn't work. A, we have to find a, right? So if I put an a in front of here, this is where the 0, 945 comes in. So y is 945, so we're going to plug in 945 to the left-hand side of the equation. Then we're going to plug in 0 to all the x's. So 0 plus 3, and there's an a. This is an a out in front right here. A times 0 plus 3 squared times 0 minus 1. Oh, that's not supposed to be cubed, sorry. 0 minus 1 times 0 minus 3 times 0 minus 7. Okay, so we plug in 0 and 900 equals 945. So 0 plus 3 squared is 9. 0 minus 1 is -1. 0 minus 3 is -3. 0 minus 7 is -7 times a. When I multiply 9 times 21, basically, times -3 negatives, that's -189a. Okay, 9 times -1 times -3 times -7 is -189a, because there's an a right here. Then we divide by 189, -189, and it goes in evenly. It goes in -5 times. So our a value is -5. So the proper equation of this function is f of x equal, or p of x, or whatever you call it, equals -5 times x plus 3 squared minus, sorry, ignore that cubed, times x minus 1 times x minus 3 times x minus 7. Degree 5, right? Degree 5. Just waiting for you guys to finish copying anything you need down. Okay, and then we're ready for the last problem. The last problem is number 7, your imaginary numbers. And actually, I'm just going to explain this because, I don't know, there's a ton of videos you can watch on this. So it's basic multiplication that we did in Algebra 1. is how do you square this? 6 minus 3i squared. Well, 6 minus 3i times 6 minus 3i, I told you guys just to FOIL it. 6 times 6 is 36. The outer term, 6 times negative 3i is negative 18i. The inner terms, negative 3i times 6 is another negative 18i. And then negative 3i times negative 3i is positive 9i squared. You want to change, you never leave I squareds in your answer. You always change it to -1. So -1 times 9 is -9. We add the 36 minus 9, we get 27 minus 36i. So that's the answer for part A. For part B, we do the same thing. FOIL it out, and you get 25 minus I squared. You never leave I squared in your problem. I squared becomes -1, so minus 1 makes +1. So this answer ends up being 26 for part B. For part C, this is a simple addition problem because there's a plus in between the two parentheses, so you just add the like terms. So -2 plus -4 is -6. -I plus +4i is +3i. So we just combine like terms. Show me that you're combining like terms. Show some work, please. And there's your answer. This one we're subtracting. For this one, I could have showed a little bit more work. I should have distributed the negative here. This negative times this negative becomes +8. So 1 plus 8 is 9. And then this negative times that negative becomes -3i. So -6i and -3i become -9i. So that is the answer to part D. You could check your work, make sure you did it right. For part E, I to the 15th, this is where I want to see some work. Some people just gave me, oh, the answer is -I. Well, you need to have some work. Okay, you need to at least do this. That 15 divided by 4 is 3 3/4. Then you should have the cycle of I to the 0 to I to the 4th. I to the 0 equals 1. I to the first equals I to the second equals -1, I to the third equals -I, and then when I do I to the 4th, I get 1 again, so that tells me the cycle starts all over from here. Well, I know from my notes from before that when you get 0 as a remainder, you get 1. When you get 0.25 as a remainder, you get I. And when you get 0.5 as a remainder, you get -1. When you get 0.75 as a remainder, you get -I, and then it cycles through again. So since we got a 0.34 remainder, that would be this one right here. So this equals -I, okay? I need to see that cycle on your paper. I to the 9th, I take 9, I divide it by 4. Why 4? Because there's 4 in the cycle, right? There's 4, after 4 terms, it cycles through. So 9, so we always divide by 4 to see where it is in the cycle, to see if 4 goes into it evenly. So 9 divided by 4, 4 doesn't go into evenly, it goes 2.25. So since it ends in a 2.25, it's going to be in this part of the cycle, the second part of the cycle. So it's going to equal I. Okay? And that is how you do your repeating I's. If you're not sure how to do repeating I's, look up repeating I's, and you should find some short videos to help you out there. All right, that is a very in-depth of what is going to be on your test. So now you have a lot to study, these 7 problems to study and to work from to prepare for your test. So you're going to turn this into the classwork section. And I need to stop my video here. Hold on, stop recording.